density of ice is less than liquid water. These are all consequences of hydrogen bonding. Density of ice is less than liquid water. Let us see. Now, in case of solid ice, the hydrogen bonding gives rise to a cage-like structure. Means each water molecule is linked tetrahedrally to 4 other water molecules as is shown in the figure. So, the molecules are not so closely packed. In liquid state they are close, but in case of solid, because of this cage-like structure, they will have vacant spaces like this. Because of this vacant space, the molecules are not so closely packed. So, for the same mass of water, the volume in case of solid, the volume will be more. Solid ice, the volume will be more. In case of water, the volume will be less for the same mass. When ice melts, this cage-like structure collapses and the molecules will come close to each other. So, for the same mass of water, the volume decreases and hence density increases. So, ice has lower density than water at 273 Kelvin or 0 degrees Celsius. Because of this cage-like structure, there are many vacant spaces in between. Because of this vacant space, the volume will be more for ice. If volume is more, density is equal to mass by volume. If the volume is more, density will be less. But when ice melts, this cage-like structure collapses and the molecules will come close to each other. So, for the same mass of water, the volume decreases and hence density increases. Means ice has lower density than water at 0 degrees Celsius or 273 Kelvin. Means ice floats on water. Then the maximum density will be at 277 Kelvin. So, there is sufficient hydrogen bonding present in the water molecules. That open cage-like structure exists which has large volume and makes the density of ice low. On heating or if you raise the temperature, what happens? The hydrogen bond starts collapsing and so the molecule starts coming together. If there is no hydrogen bonding, all the water molecules will come together, resulting in the decrease in the volume. If the volume decreases, density increases. So, if you raise the temperature from 273 to 277 Kelvin, means 0 to 4 degrees Celsius, the increase in volume due to means that when the temperature goes up to 277 Kelvin, the volume decreases. After 277 Kelvin, what happens? If you increase the temperature, the hydrogen bond will collapse and even the ice melts. Means you will have only liquid water at that point. So, the maximum density of ice will be up to 4 degrees Celsius. Above 4 degrees Celsius, the hydrogen bonding will collapse. Not only that, ice also starts melting. If you increase the temperature, if you go on increasing the temperature, the ice starts melting. So, on heating, the hydrogen bond starts collapsing and thus the molecule starts coming close to each other, resulting in the decrease of volume and hence the decrease of density. This goes up to 277 Kelvin. After 277 Kelvin, the increase in volume due to expansion of liquid water becomes much more than the decrease in volume due to hydrogen bonding. Follow carefully. If you increase the temperature above 277 Kelvin, the increase in volume due to expansion of liquid becomes much more than the decrease in volume due to hydrogen bonding. Thus, after 277 Kelvin, there is no net increase of volume on heating, which means volume does not increase means density decreases. So, density of water is maximum at 277 Kelvin.